Okay, let's see how we can answer some questions about sampling distributions for means, and then you'll complete one that's just like this. So take some sketchy notes on this, and then you'll be able to work through the assigned problem and turn that in. In this problem, we're talking about sampling from the population of all Canadian citizens. It's given the problem, and the measurement that we're using is the measurement of their systolic blood pressure. So we're thinking about the average blood pressure reading of among all Canadians. So that's the that's the setting, and we're going to study this by randomly sampling 75 from the population. So our population is given to be all Canadian citizens. Probably this means Canadian adults, but just read with what it says. All Canadian citizens is the population, and the measurement that we're taking from, or we're imagining taking from every citizen, is their systolic blood pressure reading. The numbers in the problem, the 121 is, so this is the World Health Organization study is supposedly showing this is true for everybody. So in our study, this would be mu. This would be standard deviation would be sigma, and our sample size will be n. So those are the letters that we use for those numbers that are given. The reason that it matters is that when we draw our picture of our X-bar distribution, the center of our X-bar distribution should be the mu. So the mean among all the citizens should be the center of our X-bar distribution. And the tick marks in our X-bar distribution are what we call standard error. That's the standard deviation of the sampling distribution. And we know this is the standard deviation among the individuals divided by the square root of the sample size. So in this case, that's 16 over the square root of 75, and that's about 1.85. So to draw my tick marks on here, I'm just going to round that off. Since my blood pressure reading is rounded off to the nearest whole number, I'll round that off to the nearest whole number for my picture. Later on, when we have a computer do our dirty work, we'll just use 1.85. We'll use the more exact answer. But for the parts that I have to do with my own arithmetic, I'm going to round it off. So the standard error should be the size of these tick marks. So I'm going to go up by 2s and down by 2s. And that's how my X-bar distribution would look. So that gives me a sense that if I were to go randomly sample 75 Canadian citizens and take the average blood pressure of those 75 people, that average I would expect to lay in this range, and I expect more often than not it'll be close to 121, and very rarely would be outside of that. Because this is a normal distribution, we can use our empirical rule. I see I already have a typo here. I'm not randomly sampling 200 yards of fabric. I think that's the problem you're doing to turn in. So I'm randomly sampling 75 Canadians. 68% of the time, our empirical rule tells us that 68% of the time we'll be within one standard deviation of the mean. And so that'll be between one standard deviation below the mean and one standard deviation above the mean. So between 119 and 123, in other words, between the first tick marks above and below the mean in my picture. About 95% of the time, I'll be within two standard deviations of the mean. So that'll be two standard deviations would be about 4. So it'll be about 4 below to 4 above. Notice still I'm using the rounded off figure just because I'm not involving the computer yet. And these are all, these are all rough rules anyway. So and then finally 3 standard deviations. So it's not wrong to use 1.85 for your standard deviation in this, but that's a lot of decimal places that we don't really need. So, and that really is just reflected by the picture. So the empirical rule is just telling us what the picture shows about what proportion of the data is in different ranges on our picture. The last problem is for us to go use some technology to actually read some proportions off that are more precise than the empirical rule. And for that, we're not going to use the tables anymore. We're going to always use these online calculators. So this one that's called normal dist, allows us to get probabilities into normal distribution curves. And the nice thing about it is that because it's computer-based, we don't have to convert all the problems back to z-score problems. And so that saves us that step entirely. So for example, let me just jump over. I have this on a screen by itself. So for this A part, for example, we reproduce this. So 121, 123, 125, 119, 117. So this is my picture from the previous page. The question says, find the probability that a random sample will have a mean blood pressure less than 119. So 119 is here, and being less than 119 would mean shading it to the left. So the answer to this question is the amount of area. The amount of area that's shaded in that picture is the answer to my question. To get that answer, what I need to do is go into the web app and have it draw this picture. So step one, when you're using the web app, is set the web app to draw the picture that you drew. If you can do that, then it will tell you what the area is. So that's what you're really trying to do when you're setting up the web app. The center and standard deviation is what determined the picture that I drew. So the first thing I need to do is type those in. You'll notice that when I did that here, I used my mean 121, but I used standard deviation 1.85 because that was the more precise value that I got before. And I don't care. It's the computers having to do the work, so I'm not the one that has to deal with all the decimal places. So I'll give the computer the more precise information. My picture here is shaded from a point to the left, and so the app calls that a lower tail probability. You can just guess one of these. It doesn't really matter because you're going to make sure it draws the right picture. So if your picture doesn't look like the picture on the screen for the computer, then you pick the wrong one. So it's a lower tail starting at 119. So if I set all of those things up, notice how my picture, the picture on the computer screen, looks exactly like the picture that I drew. Well, it looks better than the picture that I drew, but the shading is in the right direction. The center and standard deviations are marked correctly, and the value 119 is the cut point there. And so having all of that match, then the computer output is telling me the answer. The probability is 13.98%, about 14. And so we can either present that as a probability, 0.1398, or as a percentage. And as usual, if you're going to tell me a percentage, make sure you put a % sign on it to let me know that's what you meant. But either one of those answers would be fine. It comes right off of the computer. The other example, that's a little more subtle because it's asking us to draw the two-tailed picture, and the two-tailed picture is not exactly, there's not an option for that exactly on the app. So let me just redraw my. This is my points. It says if we collect a random sample that has a mean of 125, 125 would be here-ish. I want to know the proportion of all samples that have means that are as far away or further away from the center. Well, being that far away means being that far away this way or this way. So the question here is asking me for this two-tailed probability, this two-tailed proportion, by saying I want something that is as far away from the mean in either direction. There is no setting on the that particular web app for doing that. So what we can do is just ask it one of these questions. So I would ask it this one, because that's the one that I have the numbers for. I would ask it for how much area is here, and then I would just double it. So what that looks like in the app, again, our setup is based on getting all of these numbers to get my center and tick marks in the right place. I'm telling it I want an upper tail probability because I want it to draw this part that I've marked in green here. And I want it to start drawing that that region starting at 125. And so you can see that the picture I have at the bottom here is exactly the same exactly the same as the right hand side that I marked of the picture at the top. So the app tells me that I have 1.53% shaded. That there's 1.53% there, and so the total shading will be 2 times 1.53%, or 3.06%. So that's how I'd write it as a percentage. Notice that's a little tricky to write as a proportion. If the number comes out this way as a proportion, 3.06%, we'd have to move the decimal place twice, and so the proportion would be 0.0306. That's what it looks like when you move the decimal place twice out of that one. So you should say the probability is 0.0306, or the probability is 3.06%. Either one of those is fine as an answer. But there is an option in the web app that says type of probability is two-tailed, but it doesn't actually do what it says. So don't use that for these general probability problems. It's not, you'll be able to see the picture's not right. It's doing something else. It's doing something correctly, but it's not doing what we're trying to do in this problem. So to do a two-tailed proportion, just figure out the answer to one of the tails and double it.